Hello students, today we are going to study the divergence of vector field. So divergence of vector field. Consider an example of electric field, that is divergence of an electric field. Suppose this is a point charge and electric field lines are originated from this point charge and directed outwards from this point. So it means that the electric field lines are spreading away from this point charge. This spreading is nothing but the divergence of electric field, and this divergence of electric field can be symbolically or mathematically shown as del dot E vector, and this del dot E vector in this case is always positive. Divergence is always greater than 0 in this case. Suppose take another case, this is a point charge and all electric field lines directed towards this point charge. Okay, it means that here is the case of convergence. So convergence of electric field. So in this case, convergence of electric field, the divergence is always negative. So del dot E vector is negative. It means that divergence is less than 0. If suppose there is no divergence or convergence, in this case divergence of electric field is 0, del dot E vector is 0. So this is the example of divergence of electric field to understand the divergence. Okay, so what is the definition of divergence of vector field? Okay, divergence of vector field can be defined mathematically. The scalar product or dot product of del operator and the vector A is nothing but the divergence of the vector A or vector field A. So mathematically it can be expressed that divergence of A is equal to del dot A vector, del dot A vector, and we know that this del operator or this vector differential operator is nothing but del by del xi plus del by del yj plus del by del zk, and this A vector can be written in the xyz component as axi plus ayj plus azk. Okay, put this value of del operator and A vector in equation number 1. So therefore equation number 1 implies del dot A vector is equal to this dot this. Okay, the dot of this del operator in the vector form with A vector. So after solving this dot product, this I component with I, j component with j, and k component with k, okay, we will get the answer divergence of vector field or vector A. Del dot A is nothing but del ax by del x plus del ay by del y. We know that I dot I, j dot j, and k dot k is 1 plus del az by del z. So this is nothing but the mathematical expression of divergence of vector field or divergence of vector A. Now next we will see the physical significance of divergence. Okay, and we take the example of divergence of vector field A. So consider this is a closed surface. Okay, so V is the volume enclosed by this closed surface. So suppose this is closed surface of vector field. Okay, so consider this point P present in the vector field. Okay, and this rectangle is nothing but the area, small area around the point P. Okay, so this since this is a vector field, so this small area around point P has a direction. Suppose it is presented or it is represented by ds vector. This is the small area in the vector field. So suppose at point P the vector field, let the vector field be a vector. Suppose a vector is the vector field at point P. So consider a normal drawn to the surface. Suppose n, this is the normal drawn to the surface, and the direction of this is the small area, that is ds vector, is along the normal to the surface. Okay, and suppose theta is the angle between this, the direction of vector field, and the normal. Normal means the direction of ds vector. The direction of ds vector and the normal is same. Okay, what I have said in this diagram we can write in the text also. Okay, so consider a closed volume V having a surface area as in a vector field. Okay, now consider a point P in a vector field and ds be the vector showing small area around the point P. Okay, and the vector field at point P is represented by the vector A. Okay, we have already discussed the vector field at point P is vector A. Okay, and the direction of ds is similar to the direction of normal drawn to the surface at point P. Okay, and theta is the angle between the direction of vector field A and normal drawn to the surface at point P. Okay, now we see this is the small area, okay, around the point P. Okay, so therefore since it is a vector field, so field lines, okay, field lines is going outward through this area will be vector field dot ds dot this vector a vector dot ds vector flux out of this small area. So the flux out of the field, okay, flux of the field out of the area ds, flux out of the field, flux means the number of lines per unit volume. Okay, that is if suppose they are field lines or electric field lines, so number of electric field lines out of the area ds is given by, so ds is the area because, and at the point P the vector field is, so it is given by a dot vector a dot ds. Okay, flux out of the field, okay, flux of the field out of the area ds, that is vector a dot ds vector. And we know that by definition of dot product, this the dot product of two vector can be represented by the magnitudes of two vector and cosine of angle between them. So vector a dot ds vector is equal to a ds cos theta. Okay, now this is the flux or the field lines or field lines out of the area ds, small area. Okay, but if I want to calculate or I have to find out the total flux, total field lines out of the whole surface, whole area, okay, whole area S or whole surface area S, so we have to take the integration because this is the flux of the field out of the small area ds. And if I want to calculate, if I want to calculate or find out for whole area, so I have to take the integral. Okay, so I have to when I have to find out this total flux out of the whole surface S, so I have to take the integral over surface. So I have to take the surface integral, and we know that the surface integral can be represented by the double integral. Okay, so if I take the double integral over the surface, then I will get the total flux of the field out of whole surface. So total flux out of the field of whole surface, that is double integral over S a dot ds, and a dot ds nothing but a ds cos theta. Suppose this is the equation number 1. Okay, now we will assume, now we will again, I am showing this diagram, now we will assume this volume is very small. So if volume is very small, okay, then it is concentrated to a particular point. Okay, if volume is negligible, so it means all field lines is diverging from that point. Okay, when we say the volume is very small, so suppose volume enclosed by surface is very small, so therefore outward flux, okay, the flux out of that particular volume or particular surface, that will be equal to the divergence of that vector field if volume is very small. So this surface integral will be equal to the divergence of vector field A. Divergence of vector field A, that is del dot A vector, is nothing but the limiting value, because we are imposing the condition that volume is very small, so limit volume tends to 0. Volume is not exactly 0, it is very small, it is tending towards the 0, so 1 by V is surface integral over A dot ds, that is nothing but the divergence of A. So this is the physical significance of divergence of A. So this expression is very important, which tells us the physical significance of divergence, or if I want to quote in the statement, so the statement is the divergence of vector field, divergence of vector field is nothing but the limiting value of net outward flow of, suppose we have considered the electric flux or electric lines or field lines. Okay, so net outward flow of some physical quantity, we have considered the physical quantity electric flux or electric lines. Okay, so this electric flux, okay, through the surface area S of unit volume, that is nothing but volume flux density as the volume tends to 0. So this is the physical significance of divergence of vector field. It means that if I take the divergence of vector field, so I will get the volume flux density in terms of electric flux through the surface area of unit one. And we know that the volume flux density is nothing but the scalar quantity. So the divergence of vector field is nothing but the scalar. Divergence of vector field is scalar or scalar field. Okay, so this is the physical significance of divergence. So today we have seen what is what is the meaning of divergence and its physical significance. Thank you very much.